Okay, we're talking about the forms of evidence that a chemical reaction occurs. They're listed on the front page of your chapter handout right here. There are 5 of them. The first one is an unexpected color change. The second is the formation of a solid. Sometimes this is called an insoluble solid. Sometimes this is also called a precipitate. Okay. And the third is the formation of a gas. Sometimes they're going to say it bubbles. Just to clarify, if you open up a soda can and bubbles form, that is not a form of evidence that a chemical reaction occurred. The carbon dioxide that is dissolved in the sugar solution is simply leaving. Okay. If they tell you that you have effervescence, that is another way of describing the formation of a gas. Okay. We've also got the emission of light, and we have the emission or absorption of heat. If something is emitting heat, it will feel hot. If something is absorbing heat, it will feel cold. Student exercise number 1 wants you to underline the experimental evidence for a chemical reaction in the examples below. A says pouring vinegar on baking soda gives foamy bubbles. You would underline foamy bubbles. B, mixing 2 solutions produces insoluble particles. You would underline insoluble particles. C, mixing 2 colorless solutions gives a yellow solution. You would underline yellow solution. D, mixing 2 solutions produces a temperature increase. You would underline temperature increase. Now, moving on to writing chemical equations. When you're writing chemical equations, the reactants are on the left-hand side of the arrow. This is something that you should have learned in middle school, okay? So A plus B, those are my reactants. C and D, those are my products because they're on the right-hand side of the arrow, okay? If I want to speed up a reaction, I add a catalyst. Catalysts are not consumed in a reaction or altered. So if I add hydrogen peroxide as a catalyst to get a reaction to occur quicker, then it's going to still have hydrogen peroxide at the very end. It doesn't break apart and rearrange to help me produce more product, okay? On the next page, I've given you table 7.1, which tells you that if you have a gas, for instance, then you would have to put a little tiny g after the substance to indicate its states of matter. If you have a liquid, you would put a little tiny script L. If you have a solid, you would have to put a little s. And if you have something that is dissolved in water, like all acids are dissolved in water, and I would expect you to know that, then you would have to put an AQ. If they tell you it is a solution, you would also put AQ. If they tell you that you have a solid piece of metal, or they just said you had zinc metal, for instance, that means you also have a solid. So keep those things in mind. Now, on your periodic table, what I want you to do is I want you to highlight the diatomic elements, which are listed for you underneath table 7.1. It starts with nitrogen. It goes oxygen, fluorine, and then it comes down chlorine, bromine, iodine. So what you should have is an upside down L highlighted on the right-hand side of the periodic table. So it goes NOF, ClBr, The only element that is not included in the upside down L is hydrogen. It is on the left-hand side of the periodic table. You need to color it the same color that you've colored everything in the upside down L. Diatomic elements are 2 atoms stuck together when they're pure. So if you have pure hydrogen or you have pure chlorine, then you would write a subscript 2 after the symbol. And if you don't do that, it is considered wrong. And I'm going to show you what this looks like in student exercise number 2. So we have a chemical equation in words, and we're going to convert it to chemical formulas. So we have mercury liquid in exercise 2A. Mercury is Hg. You have to put a script L after it. And fluorine gas. The and means you're going to put a plus, and then fluorine is pure, so you look at the periodic table at what you just highlighted. Fluorine is highlighted, so you have to write a subscript 2 after it, and then you make it a little g in parentheses because it's a gas. So those two react to give. That means you're producing something different, so you have to put an arrow in there. Solid mercury 2 fluoride. Mercury 2 fluoride, you have to cross the charges. Mercury 2 is Hg plus 2. Fluoride is F minus 1. You cross the charges, you get HgF2. And they tell you that this is a solid, so you have to write a little S after it. So that's your equation that you have to write, okay? Moving on to B, it says you have zinc metal. So we're going to write the symbol Zn for zinc, and we're going to write a solid because I told you previously that metal is a solid. It reacts with sulfuric acid, so we have to put a plus. Sulfuric acid is hydrogen with the sulfate ion. Remember, you have to cross the charges and you get H2SO4. We're going to add an AQ after it because all acids are dissolved in water. It's giving, so I'm adding an arrow, aqueous zinc sulfate. You need to cross the charges. Zinc is Zn plus 2. Sulfate is negative 2. So you're going to get ZnSO4. And it's aqueous, so we're going to put a little AQ after it. And then you're producing hydrogen gas. So since there's an and, you put plus hydrogen on the periodic table. You just highlighted it. It's a diatomic element. So you have to write H subscript 2 and then a little G after it. Okay? Okay, this is an introduction to what you're going to be learning next class. So next you can do the worksheet on forms of evidence of chemical reactions. There may be more than one form of evidence that a chemical reaction occurred in an example, which is fine. You're just going to give me the ones that you've observed on the worksheet, and then you can move on to the next